Hello everyone, welcome to this video. So today I want to show you guys this very nice barrel shifter design that I found the other day on the OR server. This is the so-called Dorito shifter. So you can see it has this kind of triangular shape which looks a little bit like a Dorito. And it is a very compact and very fast design of a barrel shifter. I'm not the one who designed this, and unfortunately I was not able to find out who did. But anyway, so let me give you a quick demonstration of what it can do. So this thing is a barrel shifter, which means what it does is that it takes an input and it can shift this input by an arbitrary amount of bits, either up or down, and it does this in constant time. So no matter what input we do, it gives us the result in a fixed time. So let's, for example, input this number. This is 12 in binary. And there are two modes that we can choose. We can either shift down, so this is when the lever points up, or we can shift up, which is when the lever points down. So currently it's downshifting, and here we can pick by how much we want to downshift our number. So if we flick this first lever, we shift by 0, which means that our output will be precisely our input. We can, for example, also shift down by 1. So this takes our input and it's now shifted 1 bit down. Okay. Um, so now if we shift it down by 2, it lands here. But if we shift it by 3, you can see that we have two lamps as our input, but only one output. So what happens is that this upper bit, it gets shifted to here, but this bit, it gets shifted into nothing, essentially. So we kind of lose this information. So what we can do is we can do something called rotation. So rotation means that if we go below this first bit, we start back at the top again. So if I flick this lever on, you can see this upper lamp turns on. So this lamp gets shifted to here, and this lamp gets shifted kind of below here and up to the top again. Okay, and with this lever we can control if we want this behavior or not. So let me turn this off. So we can also do an upshift. So if I turn this on, it's now shifting up. And here you can see on the signs the amount by which it shifts up or down. So if I want to shift up by 1, I don't have to start here. I have to go to the last lever basically. So to this lever, if I flick this, you can see our input gets shifted 1 upwards. Or we can maybe shift it by 3 up. So you can see this. And also if we shift it too much up, so if we shift it, for example, up by 7, our bits are above this 8th bit. And now what we can do is we can enable rotation mode again, so the bits, they kind of start here at the bottom again. And as you can see, this upshift by 7, it is basically the same thing as just a downshift by 1. And this is also what you can read here on the sign. So essentially, to do a rotation, what we do is we do an upshift and a downshift simultaneously. And we basically OR the outputs together. And you can see that the amount that we are shifting up and the amount that we are shifting down, their sum is always 8. So here we have 1 plus 7, which is 8. Here we have 2 plus 6, which is 8. 3 plus 5, which is 8, and so on and so on. So with this trick, we can kind of simulate this rotation. So there's one more thing that this shifter can do, which is the so-called arithmetic shift. So basically, when you have a binary number and you shift it down by a certain amount, this corresponds to a division by 2 or by powers of 2, essentially. So if I enter, for example, 6 into here and I shift it down by 1, what you obtain is 3, which is precisely 6 divided by 2. So by performing this downshift, we took our input and we did division by 2. But this is only true for positive numbers or for unsigned numbers. So let's say we have minus 6. So minus 6, to obtain it, we just input 6 and we flip every bit, like so. And then we add plus 1 to it. Here on the right-hand side, we now have our representation of minus 6 in the 2's complement. But now when we shift it down, we obtain some number, but this number is most definitely not minus 3. Minus 3 also needs this upper lamp to be on. So if this upper lamp was on, and here on the left hand side we would have -3, and then this right shift would correspond to a division by 2. But basically when we do a right shift, we always shift a 0 into this first place or into the upper bits. And the idea is that for a negative number we want to shift once into the upper bits. And this is what is called the arithmetic shift. And for that we have one additional bit here at the top, which stands for our sign. So if this lamp is off, we have a positive number, and if it is on, it is a negative number. So currently we have our number with a positive sign. So now we are just shifting it down, and this corresponds to division by 2 as we are used to it. But we can also turn on the arithmetic shift. So if I turn this on and I now input a negative sign, you can see that this upper lamp also turned on. And now what we have here is that this number is -6 and this left number is -3. So we now performed division by 3. So let me maybe give you another example. So if I turn this thing on, so this is, I think it was 244 with a negative sign, so -244, and let's shift it down by 2. So what's going to happen is that our number itself gets shifted down. It gets shifted down by 2, but we also shift 2 once into the upper bits. Okay, and now here on the left hand side we have -61, and here we have 244. So I already did this example, and yeah, 244 divided by 4 is exactly 61. So this works just fine. And if we want to kind of ignore the sign bit and just perform a normal left shift, we can turn this off again, and now you can see it just takes our number and shifts it down by 2. So I will not be doing a block by block tutorial for this, but I can maybe show you a little bit and explain how it works, and you can just pause the video and build it for yourself. So basically we have 2 slices here, this left slice and this right slice. The left slice is for upshifting and this right slice is for downshifting. This red part is for the arithmetic shift, and this green part here is for the rotation mode, essentially. So I can maybe show you both slices individually. So this is the upshifter, and basically it is just a very compact, a very efficient design of a matrix decoder. So a matrix decoder, I build a very simple one over here. So what it does is that it takes in 2 inputs. It takes in a y coordinate and an x coordinate, and it basically turns on precisely that pixel essentially. So if I put in, let's say, so if this is 0, 1, 2, if I input 2 as our y coordinate, and let's say 0, 1, 2, 3, 4 as our x coordinate, you can see that the lamp, or kind of a pixel, at 4, 2 turns on. So this is 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 1, 4, 2, 4. So basically we have a bunch of AND gates, and these AND gates, they turn on kind of exactly one lamp. And what we now would do for the shifter is that we would connect this to the corresponding bit. So for example, this means that we input some bit, and by activating this 5th lever, we want to do an upshift by 4. So what we would do is we would take kind of this output here, and we would connect it to the 4th bit. Or sorry, not to the 4th bit, but to a bit that is 4 bits higher to do this upshift, essentially. And yeah, this is exactly the same thing that we do for the barrel shifter design, for the upshifter, for the downshifter, but it is done in a much more efficient way. So by doing this diagonally, we essentially save a lot of space, do this very, very efficient, and get a nice design. So here I have just the upshifter, so you can see kind of, if I, for example, consider the slowest bit, here we have this redstone line that goes up, and basically here at the back we have, so here we have the torches, and here at the back we have also power lines, which basically deactivate the torches. And now if I, for example, shift up by 2, we don't have any power on this torch, and now this AND gate kind of gives an output, and we connect this up to the corresponding bit. So this is an upshift by 2. The same thing for the downshifter. So here, instead of wiring things diagonally up, we go diagonally down, like this. And basically, instead of doing, so here we have like solid block going into glass block. Here we do it the other way around. We have glass block going into solid block, and then we go one step lower. Is there anything left to say for this? I can just fly around here a little bit. You can pause the video if you want, copy it. It's not too hard. It's very kind of the same thing, but repeated over and over again. Okay, so I think that should be enough. So one more thing. So maybe you need a bigger barrel shifter. For example, this is only for 8-bit numbers, but let's say you want 16 bits. What you would have to do is you would have to extend these wires. And what you can do for the downshifters, you can just go one step lower, like this. Place a repeater right here, and a block with redstone on top and a redstone torch. So you can just extend this design very nicely, and you still just have a one block gap in between. For the upshifter, however, it's a little bit more complicated, because here you don't really have a lot of space to place repeaters. So for example, if I place a repeater right here, this is going to both this line and this line at the same time, which we of course don't want. So the only thing that we can really do is we have to introduce kind of a bigger gap here. So here we have a one block gap between like each individual shift, but here we would need like a, I don't know, a 2 or 3 block gap to have space for the repeaters, which is of course a little bit annoying, but whatever. So if we also want to include the arithmetic shift, what we can do is we can do our downshifter, and we can add kind of this red line to it, these red blocks. And this is something that was shown to me by the very talented redstoner Mixelmaniac. And basically what we want to do is, for example, when we have a negative number, and let's say we shift down by 3, what we want to do is we also want to power these 3 upper lamps. And we do this by basically just connecting the sign bits to these other lamps using these repeaters. And what's important here, so maybe it's important that we place these glass blocks here. They act as diodes, so they don't let the signal go down to this block. So if, for example, this would be a solid block, then what would happen is that we also power the line below that. So here we have 4 lamps on, but we only want 3. So we need these glass blocks. And if you're playing on Bedrock Edition, these signals are also going to travel down, but what you can do is you can just replace these glass blocks with slabs, and then it's going to work just fine. And so this is how we can do an arithmetic shift. So now you can see the sign bit, it gets shifted 3 times down consecutively. If we have some other numbers here, let's say this number, it gets shifted down as usual. So now you can just take both slices and combine them into a single barrel shifter. So what I just did here is I connected the outputs together using a target block into a repeater, and I also connected the inputs. And here you can use kind of this technique to make 2 signals pass each other without interfering. Okay, and now for rotation mode, what you want to do is you basically want to connect certain downshifts to certain upshifts. So for 0, 0, you can just basically, it doesn't really matter. You don't need this line, but you can just connect them together if you want to. For a downshift by 1 and an upshift by for a downshift by 1, you want to connect this to the upshift by 7. So you want both of these numbers to always add up to 8. Same thing for 2, so downshifting by 2. We want to simultaneously upshift by 6. So here 2 plus 6 is 8 again, 3 plus 5 is 8, and so on. And for example, if I turn this thing on, this means that we are now downshifting by 1, and here we have this wire that connects to the 7th, to the 7 up shift. Yeah, yeah, exactly. Okay, so or downshifting by 2, like this. This connects to upshifting by 6. So if you do this for all the shifts, then you can also do rotations. And basically on these green lines, I always introduced 1 tick of delay, so 1 repeater, to make the signal strength reach. And this introduces 1 tick of delay, which means if you shift your number, you first shift it down, and 1 tick later only you shift it up, which means that our output is not going to be synchronized, but we can easily fix this by going to these repeaters and putting them all on 2 ticks. So here on the left side, these repeaters are all on 1 tick, but on the right side we have 2 ticks of delay. So if I input some number, let's say we input this number, we activate rotation mode, and we shift down by 1. So I'm going to pause the game here, so we can see that this lamp and this lamp, they both turn on precisely at the same time. Yeah, there you saw it. So both of them turned on in precisely the same tick, so our output is completely synchronized. Okay, so the last thing is, how do we actually enable the rotation mode? So the idea is quite simple. So we have these gray lines, and what they do is that they basically power these glass towers. So basically, if let's say I turn this on, you can see these repeaters power these glass lanes, and what they do is they just completely block, in this case, the downshifting. So no matter what we do here, we are never going to perform a downshift because there's always power on these glass lines. And if I flick this lever, then the other side is going to be powered. And we can easily enable rotation mode by just depowering both these gray lines. Okay, so here I just have this black line, and what it does, it completely cuts off any signal that we get from here. So no matter if we do an upshift or a downshift, these gray lines, they are never powered. And yeah, so we perform the upshift and the downshift at the same time. If I turn this off again, now we are blocking the upshifting part by always powering these glass towers. Okay, is there anything left to say? Not really. I think this was it. I hope you enjoyed this video, learned something. Have a nice day. See ya.